Bismillahirrahmanirrahim. Iyaka na'budu wa iyaka nasta'in. Welcome you all to Bamus Studiar. I am Kuratulen, and now today the topic of our discussion is about functional group, and today in this topic we are going to study about those functional groups which contain carbon, hydrogen and oxygen. And mostly in part 1 we are just going to discuss about alcohols and ether linkages. So firstly, alcoholic group, this is hydroxyl group, or you can say the class which belongs to hydroxyl group is alcohols. Commonly they are called as alcohols, but when you go for their IUPAC name, as you know that they are the derivatives, so simply what you do is that you have to eliminate E of alkane of parent hydrocarbon with OL. So IUPAC name changes to alkanol. So when you go for its functional group, it's having a spare valency along with OH group. General formula is having ROH, where R is the alkyl group that might be one carbon methyl, ethyl and so on. So the for R you are having the general formula CnH2n plus 1. This is for R, and OH is the functional group. So when you go for the types of alcohols, you get to know about the primary alcohol, secondary alcohol and tertiary alcohols. Primary alcohols are those in which you are having a alpha carbon, a carbon which is directly attached to OH is further attached with one other carbon. So over here you are having the carbon which is directly attached to OH is having one spare valency which can be attached to further one other carbon. The point to be noted over here is when you go for the general formula, you have to place R over here, and the examples are instead of using R, you have to put the methyl group, ethyl group depending upon the carbon atoms. So CH3OH is one of the simplest alcohol where R is composed of only one carbon atom. So it is methyl alcohol commonly. This is the common name. And when you go for its IUPAC name, simply you have to remove the E of methane with OL. That OL is representing that it belongs to alcoholic group. So methanol. Second is ethyl alcohol, ethanol. Now we are having another classification of alcohols as secondary alcohols. The functional group is when the carbon attached with OH is further capable of attaching with two other carbons or having two spare valencies. And when you go for its general formula, you have to put 2R over there. And when you go for the examples, you are using a smallest R group, which is methyl group, on either side. So as you can see that this is 3 carbon is actually propyl, but when you eliminate the hydrogen from the central carbon and place any of the functional group over there, this is isopropyl alcohol. Isopropyl alcohol is the common name, but when you go for its IUPAC naming, the rule for IUPAC naming is that you have to select a longest chain of carbon atoms and you have to number it from that side which give lowest position to carbon on which that functional group is actually present. So as it composed of 3 carbons, so it doesn't matter that you start numbering from right side or from left side. So the suggested IUPAC name would be 2-propanol, because at carbon number 2 that function group is present. Prop is representing the presence of 3 carbon long chain and oil is representing the alcoholic group. Over here we are having another example where we come across to the 4 carbon atoms and we have to go for the numbering. When we number it, or it's compulsory that we have to number it from that side which give lowest position to that carbon which is directly attached with OH. So numbering should be started from the right side, and when we number the chain we come to know that it is 2-butanol because at carbon number 2 OH group is present and this parent chain is of 4 carbon atoms, and as well as their common name is concerned, so this is called as secondary butyl alcohol. As far as the tertiary alcohols are concerned, the carbon which is directly attached with OH is further capable of attaching with 3 other carbon atoms. We are having that general formula along with 3R group, and when we replace that R groups with 3 CH3 groups, we are having the situation of tertiary butyl alcohol, because when you are having 4 carbon atoms and hydrogen from the central carbon atom is eliminated, then it is forming tertiary butyl, and as OH group is present, so alcohol word is representing the class name, so it's compulsory for the common names that we have to represent its class name. So as far as its IUPAC naming is concerned, we are having none other than option that we have to count it, and the numbering should never be exceed from 3 carbon atoms. So it's a 3 carbon long chain, and at carbon number 2 you are having methyl group and alcohol group. So when you go for this numbering, methyl group is acting as a substituent while OH is acting as a functional group, so which is in higher priority rank. So the numbering should be like 2 methyl 2 propanol, because at carbon number 2 you are having methyl as a substituent, at 2 position you are having alcoholic group, and this is a parent chain of 3 carbon atoms. Then we come across to one of the another function group in which you are having O in the center with the spare valencies on both sides, and these are called as ether linkages. The class is ethers. They are commonly called as ethers. Whenever you go for its common name, you always have to put the class name which is ethers, but when you go for IUPAC name, the trend is this, that you have to remove the alkane with alkoxy alkane, and that oxy representing the presence of oxygen within a chain. So as far as the functional group is concerned, you see that oxygen in the center where they're having 2 valences on both sides. When you are going for its general formula, they are having R on both sides. R may be different or it may be same, and when you are having this type of situation within R is similar, so it's a bit easier for you. But when it is different, then you go for the alphabetical orders in case of suggesting its common name. So you are having this R group and this R group in the situation when you are having both R which are similar, then one R is going along with O and called as alkoxy, and another R is named as completely alkane. So it's better when you are having R in different situations, so this O are going with the group alkyl group which are having smaller values, like if on one side you are having methyl group and another side you are having ethyl group, so O will go with methyl group and ethyl group will be named as ethane completely. Okay, so let us check it with certain examples. Like over here we are having CH3 on both sides, and it's a plus point that we are having that R group which is similar, so we commonly called as dimethyl ether. Ether is the class name, and it's compulsory for the common names that the class name should be there, so dimethyl ether. But when you go for its IUPAC name, what you do is that as the both R groups are same, so O is going with one CH3, so it would be methoxymethane. But the situation is different when you are having 2 different R groups over here. So O will go with the smaller group CH3, and CH2CH3 will be named as ethane. So the common name is methoxyethane and the IUPAC name is ethyl methyl ether. In that particular situation, you have to, in common names, you have to follow alphabetical orders. E comes before then M, so ethyl comes before then methyl. But in case of suggesting IUPAC namings, O should always be go with those R group which are having small number of carbon atoms. Third option is there when both groups are same, so this is diethyl ether, or you can say ethoxyethane. I hope this now let me tell you this last naming. This is again the R group is different, so it is named as methyl N-propyl ether. M comes before then P, so another option is methoxypropane. I hope that you are now in a situation to understand the common names and IUPAC names. This is basically a series of the function groups we come across within other examples, another part of carbon, hydrogen, oxygen functional groups. Inshallah we meet with a new topic. Allah Hafiz.